solve it yourself, spend about 2 minutes, and then move on. In the right-hand corner, I've written what we're trying to figure out, which is how to make 1.08 to the tth power equal 2, and solve for t. And then here I've written a simple situation which is going to help us understand how we do this. So this says 3 to the x power is equal to 27. Well, what is x? X is the value that I need to raise 3 to get 27. You can do this in your head. That would be 3. Okay? Well, what we want is some sort of mathematical operation which will tell me the missing exponent, which will help me figure out what the missing exponent is. So what we'd like to do is we'd like to say, can we find a mathematical operation which will say, find the exponent which I will raise 3 to get 27. And the way that we write that, it's called a logarithm, and we use log for logarithm. And what's the base? Well, the base is 3. So we have log base 3. And we want to take this base and we want to raise it to some power, and we want it to equal 27. So log base 3 of 27 says, what is the exponent that I must raise 23 to equal 27? So in other words, the value that this equals will be the x that I am searching for, and that just so happens to be 3. So let's define that specifically. So if I have some logarithm, base a of b, that is the exponent which we must raise a, which we must raise a to, and just to make sure you understand what that means I'm taking this exponent, we'll call it x here, I'm raising a to this exponent. So whatever this logarithm is, it's the exponent that I raise a to in order to equal b. Okay? So this logarithm, this says the log base a of b, it tells me the exponent. What is the exponent that I need to raise a to in order to get b? Okay? And so now you'll notice, what you should notice is that there is a relationship. Okay? So if I have a to some x power and it equals some number b, okay? Let's say you know a and you know b, but you don't know x. Well, then you can rewrite this using the logarithm, because the logarithm says, hey, do you have a base but want to raise it to an exponent and equal some other number? Well, now you can write it as such. So we can rewrite this in logarithmic form as log base a of b, which will equal whatever the missing exponent is. So now we can take our situation up here and we can rewrite it, right? If I have 1.08 t equals 2, I can rewrite this in logarithmic form as log base 1.08 of 2, which will equal t. Okay? So let's think about what this says. This says, what number must I raise 1.08 to in order to get 2? And that, of course, is going to be t. And now I've got to figure that out. So the key here is, well, how do we figure this out? We've solved for t, but what is this? And to figure that out, we need to learn a new concept. All right, so this new concept, this new thing, it's called the number e. And it's the first part. And this is e, it's a constant number, and it stands for Euler's constant. Okay. There's a famous mathematician, one of the most famous in the world. His name was Leonard Euler, and he came up with this number. And as you go on in calculus, you'll study it. And it's a constant, means it's a number that never changes, and it's also an irrational number, so there's no way we can ever write it completely down. It goes on forever and ever, but it's approximately 2.718. It goes on forever and ever, of course. And Euler's constant is pretty important, and here's why. And the reason it's very important is because if you make e the base of your logarithm, it does some very cool things. And this is what's called the natural logarithm, or I'll abbreviate natural log. And the natural logarithm is what we get when we use the log, but we use base e. Okay, so you have some number, that you're trying. So let's say log base e of a. So that's saying what is the power that we must raise e to get some value a. And the way we write this is we write it as ln, lowercase ln of a. Okay? That means natural log of a. And so that's how we'd say it. Now, ln is the same thing as writing log base e. Okay, so that's how we'll write it. And the natural log has some very good, very useful properties. So the first property, this is a simple one to start us off, is natural log, I don't want to move that, is the natural log of 1. And that says, what that is asking is, what number must I raise e to, what power must I raise e to so that I get 1? And that, of course, is 0. 0 is the only number that when I raise some number to 0, the 0th power, I get 1. Okay, so that's the first property, and it's a pretty simple one. But we have a couple more that are much, much more important. Okay, and so the second one is this property, and so this is interesting. So let's say I have a log of some base other than e. So let's say I have log base a of some other number b, just like I have up here. Okay. Now, unfortunately, your calculator doesn't have a function for this. Okay, it has no function for this. There's nothing you can do with your calculator to go and say find log 1.08 base 1.08 of 2. Okay, but your calculator does have the capability to find the natural log of a. And so what happens is when you are met with this, you want to somehow put it in terms of natural log. And so there's a property that says the natural log, log base a of b is the same as natural log of b divided by the natural log of a. And in your calculator, there's a way for you to say find the natural log of a number b. Okay? And this is helpful because no matter what logarithm you're dealing with, you can always put it in this form. So I want you to go ahead and pause the video and use this property to try and find the answer that we're looking for. Okay, so we had log 1.08, base 1.08 of 2 equals t. All right, so hopefully you said, okay, I can rewrite this. So I can rewrite this as natural log of 2 divided by natural log of 1.08, and that will equal t. And guess what? If you go to your calculator, or you go to Wolfram Alpha, you can type this in, literally, ln of 2, you put parentheses around the 2, ln2 divided by ln 1.08, and you will get 9.00 something 6. Okay? That's the number of years. That's what the time needs to be. And you'll remember that that is what you found by guessing and checking. If you tried it out, you would find that you'd get 9. Now, there's one last property that is important, and that is this. If you have the natural log of some number a to the x power, okay, that is the same as x times the natural log of that number. which essentially is saying if you're taking the natural log of some number to a power, you can just bring the power down and multiply. And so what I want you to do is I want you to take a look at what we started out with, 1.08 to the t equals 2, and I want you to try and use this property to solve for t. Okay, that's going to be what I'm looking for tomorrow. And then after that, I want you to write down any questions that you have. And if you don't have any questions, just go ahead and write down what you anticipate will be the most asked question.